Hi guys, this is Dr. Manjunath Chennapgod from Anveshana Academy, Bangalore, India. Dear students, in the previous class, we solved one numerical on diesel cycle. Now I will move towards next numerical on diesel cycle. Okay, so next numerical on diesel cycle. Okay, so now first, dear students, I will read the problem first, then I will solve this numerical with in detail steps. Okay, the stroke and cylinder diameter of compression ignition engine working on the theoretical diesel cycle are 250 mm and 150 mm respectively. The clearance volume is 0.004 meter cube. Full stop. The fuel injection at constant pressure takes place for 5% of the stroke. Full stop. Calculate the efficiency of the engine. Dear students, he has given one 4-stroke diesel engine and he has given some bore diameter and stroke length and he has given clearance volume also, and he is telling that there is a fuel injection at constant pressure for 5% of the stroke. If it's so, then calculate the efficiency of the engine. So how to calculate that? So we will solve the numerical step by step. We will try to understand the problem by having in a schematic diagram. That schematic diagram you can see here, dear students. What all things he has given, he is telling now. So there is a diesel cycle, yes, diesel engine that working on a 250 mm. What is the 250 mm stroke length? He is telling that first is stroke length, then second is cylinder diameter. Stroke length is 250 mm, then cylinder diameter is 150 mm. So what is that now? You can see what is stroke length. The stroke length is the length between BDC to TDC, or distance between TDC to BDC, that we can call as the stroke length, that is represented as a capital L, that he has given here 250 mm he has given. Okay, fine. Next he has given bore diameter or cylinder diameter is 150 mm. That D you can see now. That D he has given 150 mm he has given. But you have to convert that mm into meter while solving the numerical first. Okay, fine. Then first and second parameter is over. What is one more parameter? He is telling clearance volume. That is how much? 0.0004 meter cube. So therefore we can write it here. Clearance volume is equal to, where we can get the clearance volume? The clearance volume is the volume between TDC to the cylinder head. That is something called clearance volume, that is represented as a VC. So VC is equal to 0.004 meter cube. And it is a diesel engine, so here it is a fuel injector. Compression ignition engine, it is having a fuel injection system that you can see here, dear students. Okay, fine. This is the this is the schematic diagram to understand the problem very well. Okay, fine. Now here when the piston is moved from BDC to TDC at constant pressure, what we are doing? We are going to inject fuel for 5% of the total stroke length. That what he is telling now. If it's so, you have to calculate the efficiency. How to calculate the efficiency? Because here now, when you are going to supply heat, right, with help of fuel injector, you are going to supply diesel. When you are going to supply diesel to the compression air, then what happens? Then sudden combustion will take place. Because of that combustion, we are going to get some amount of work. That some amount of work is represented as a W. To get this work, we are going to supply certain amount of heat as an input. That heat we can represent it as a QS. So if it's so, then what we can do with help of these two data, we can calculate the efficiency. We know efficiency of the engine. What is the efficiency of the engine? Efficiency of the engine is equal to work done to the heat supplied. That is what? QS. Work done to the heat supply. This is the problem. So quick recall, dear students, what you can see now. I have to first of this, I need to list out the given data. The given problem is diesel engine, that is compression ignition engine. Then stroke length, that is capital L, is equal to 250 mm, that is converted into meter, that is 0.25 meter. Then cylinder diameter is 150 mm, converted into meter, that is 0.15 meter. Then clearance volume he is given in terms of meter cube itself. That is how much? So you can take VC. That VC is equal to 0.004 meter cube. Then fuel injection, it is taking place at constant pressure. That means what? P2 is equal to P3. At constant pressure, heat addition takes place. That too for what? 5% of the stroke. This is the given data he has given. Then he is asking to find out or calculate or determine the efficiency of the engine. He has given an engine. That engine is working at that particular condition, that parameter he has given. With the help of this given data, what I have to do? I need to calculate the efficiency of the engine. So to calculate that efficiency of the engine, dear students, you have to understand the engine parameters first. So for that purpose only I have given the diagram. What is engine parameters? When it comes to engine parameter, right, you need to identify whether the engine type, whether internal or external combustion engine. If it is internal combustion engine, whether it is petrol engine or diesel engine, that you have to identify. Next step, stroke length. What is stroke length? The distance between TDC to BDC, that is stroke length, that is L. Yes, fine. Then cylinder diameter. Yes, I already told you the inside diameter of the cylinder is cylinder diameter. And clearance volume. What is clearance volume? That is clearance volume is represented as a VC. The volume between TDC to the cylinder head is nothing but what? Clearance volume. That data, parameters you should know, dear students, before solving the problem. Okay, once you know these all data, right, you can calculate the volume. What type of volume you can calculate? You can calculate the total volume and displacement volume. Total volume is nothing but what, dear students? Now here we can call it as a at point 1, right? At point 1 we are going to mark point 1, right? This is a point 1. Sometime we are going to mark, sorry, 1 minute. This is what? Point 2. Volume at point 1 is V1. Volume at point 2 is nothing but what? V2. So that V2 is nothing but what? V2, the volume between cylinder to the V2. That V2 I can call it as here as VC. Then this V1 is nothing but what? The V1 is the volume between BDC to TDC. That I can call it as a swept volume. If I want to calculate the total volume, how I can calculate the total volume? I can calculate, sorry, 1 minute. Total volume I can calculate here as, so that VT is equal to, what I can do now? VC, V1 plus V2. What is V1? V total is equal to, what is V1? That is Vs plus what is V2? That is Vc. So that is the total volume. Okay, with help of this all volume, what I can do? I can calculate the compression ratio. Okay, I can calculate the compression ratio. So next parameter is what? Compression ratio. To calculate that compression ratio, I should know the value of all volumes here now. Clearance volume and soft volume I should know. With help of that formula, I can calculate the compression ratio. Once you know the value of compression ratio, you can easily calculate the efficiency of the diesel cycle. With help of Dirac equation or with help of a standard equation, I can calculate the efficiency of the diesel cycle based upon the given data. Okay, now once again, what type of engine now? What you have to identify? As I told you to identify. Yes, I identified the engine is diesel compression ignition engine. That means what? CI engine we can say, or diesel engine we can say. Next, what is stroke length he has given? Yes, he has given 250 mm. 250 mm he has given, converted into meter, 0.25 meter. The next, cylinder diameter he has given 150 mm, that we converted into 0.15 meter. Then a clearance volume he has given, then he has given a fuel injection. With the help of this data, I need to calculate the efficiency of the diesel cycle. How it is, that we can see. This given it already he has given. But to solve this numerical, what you have to do? You have to draw one PV diagram and TS diagram. I will draw here PV diagram. Okay, what all? P1 temperature 0.192. What all things he has given, that you have to list out. P1, T1, all the things now. So this given data I have written it. Okay, now second step is to calculate the efficiency. It's only one determination is there, that is efficiency. To calculate that efficiency, we know the standard equation. This equation already we have derived, but in this equation, what are the main parameters? Main parameter is gamma. When it comes to gamma, that gamma is constant for A, that is 1.4. Then RC. What is RC here? RC, we know the formula V1 by V2, that we can calculate. But next, one more parameter is there, cutoff ratio. Cutoff ratio is equal to what? V3 by V2. So to calculate this, I require all these values. Then what I will do now? So first I will try to calculate the value of RC. What is RC? RC is equal to V1 by V2. What is V1, dear students? What I told, that is VC. Then V2 is equal to Vs. Here it is interchanged. Sorry, V1 total volume. So one second, he has written like this. but RC is equal to, that is total volume divided by clearance volume. What is total volume, dear students? RC is equal to, what is that our total volume? VC plus Vs divided by Vc. So therefore Vs Vc, here it is small changes, just you can correct it. Vc plus RC is equal to total volume divided by clearance volume. What is total volume? Total volume is nothing but what? Summation of clearance volume plus swept volume. Vc plus Vs divided by Vc. So here to calculate Vc, he has given in the problem itself, but we don't know the value of Vs. That we can calculate with help of a standard equation. What is that standard equation? That is nothing but what? It's a cylinder object, right? The cylinder, the cylinder and piston is cylinder object. We know the formula, that is Vs is equal to 5 by 4 into d square into L. What is d here now? Bore diameter. Some authors they will take capital D, some authors they will take small d. It's up to you. In nomenclature you can give clearly you can write, you can mention. Okay. Now 5 by 4 d is 150, that is 0.15 meter square into stroke length, that is 0.25. Do simplification, you are going to get the value of Vs. Vs is equal to 4.417 10 to the 4 of minus meter cube. This is what swept volume. Once you know the value of swept volume, what you can do? You can calculate the compression ratio. How to calculate the compression ratio? That you can see now. To calculate that compression ratio, we know already. What is that compression ratio? What I told now, compression ratio is equal to what? RC is equal to Vc plus Vs divided by Vc. The same thing I am doing here now. So Vc plus Vs divided by Vc. Do simplification. We are going to get the value of compression ratio is 12.04. 12.04. Now to solve this numerical, one more unknown data is there now. Now RC is okay, fine, but one more rho is need to calculate it. To calculate that rho, we have one more equation. Either we can calculate with help of volume equations, volume data, or I can calculate that cutoff ratio with help of an equation. That equation is cutoff ratio is equal to rho is equal to 1 plus k into bracket RC minus 1. So what is this k? Because it's telling heat addition. Okay, heat addition, that constant pressure, that to 5% of stroke, that is nothing but what? K. That means rho is equal to 1 plus this k is nothing but what? 5%. 5% of 100 is nothing but what? Divided by 0.05. So 0.05 into RC is 12.04, that you already calculated, minus 1. Do simplification, you are going to get the value of rho. Rho is equal to 1.552. Once you know the value of rho, you can go with the first equation. In the equation, as I told dear students, now you know all the values. Once you know all the values, substitute all the values in equation number 1. Then what will happen? Substitute all the values in equation number 1. You are going to get the efficiency of the diesel cycle as neta is equal to 59.33%. This is what my final answer, dear students. Hope you understood this problem. If you have any doubts, please ask me. Okay, do comment and ask. Please subscribe my YouTube channel Anveshan Academy, and your support is highly appreciable. Okay, thank you.